Hi, in this video we are going to see about a Python IEEE project which is entitled as Yoga Pose Detection using Deep Learning, which is an enhancement of IEEE base paper titled Yoga Pose Recognition using Deep Learning, which is an IEEE 2024 conference paper. So before seeing the execution of the project, let me brief about this project. So we all know about the yoga. It is a practice that is made by the humans for the well-being of the both physical body and also the mental health. So as the yoga cures both the physical and the mental health issues, all over the world people prefer for doing yoga. But the problem is, if they wanted to do yoga, there are various postures available, so they need to have a perfect trainer so that they can learn the yoga and do it. In case if they are doing wrongly, so it may give some pains or side effects to them. So we need to have a automated or AI trainer where we can train up all the yoga poses so that it can detect the exact yoga posture and it will name it. So in this base paper, so the authors have developed the yoga pose recognition using deep learning. So in this base paper, the authors have used the combination of CNN and LSTM for the detecting the yoga poses, and here in the base paper the authors have used these Bajrangasana, Padmasana, Shavasana, Tadasana, Trikosana, Virkshasana, these kinds of yoga poses. But kindly note that we are not going to use the same as mentioned in the base paper. So now let us see about what the enhancement that we have done it and implemented it. So first thing, the model. So we have used VG16 model, and the accuracy score that we have achieved is 98%, and the test score that we have achieved is 96%. Second model that we have used is SVC, Support Vector Classifier. Here we have achieved the train score of 92.3% and test score of 81.2%. So here in the yoga pose detection using deep learning, in our proposed model, we are going to detect using two different modes. One is using the image based mode and other one using the webcam based mode. So here you can see in the proposed abstract, you can see we are going to use about image and the webcam input. So the first model using the image is developed using VGG16 model architecture, and the second model SVC, that is for the webcam based model, which is with the Mediapipe framework we have implemented SVC, Support Vector Classifier. So these are the two different models that we are going to implement in the proposed system, and from the existing system we are going to implement image based and also the real-time webcam based. And another modification that we are going, enhancement that we are going to use is we are going to use 5 different poses, that is down dog, goddess, plank, tree and warrior. So these are the 5 different yoga postures that we are going to train up the system. So now let us see about the dataset part. So in the dataset part we have the test and train for each classes. So the total image that we have trained up the system, so totally it contains around 1081 images, and test images is around 470 images. So now let us see about the images that is available in each folder. So now in the train folder we have in down dog. So down dog contains 223 images. So these are all the images of the down dog yoga posture. And next one is goddess, which contains 180 images of the goddess yoga poses. Next one is plank. So these are the images which contains around 266 images of the plank images. and next one is tree yoga pose, which is around 160 images that is available in the train part of the tree, and final one is warrior 2. So these are all the posters of the warrior 2, which is around 252 images. And in the test part also we have the same classes with the down dog 97 images, goddess with 80 images, plank with 115 images, tree with 69 images, warrior 2 with 109 images. So these are all about the data set part. So now we have seen about the model, the accuracy values, the data set part, and the detection mode. So all these things been mentioned, and as mentioned we'll be using Python for the backend development, and the front end part contain HTML, CSS and JavaScript, and the web, for the web framework we have used Flask web framework. So these are all been summarized in the our proposed abstract. So coming to the existing system, so we are considering the base paper as existing system. So the base paper used the CNN and LSTM model. So those details have been elaborated in the existing system part. And coming to the disadvantages of the existing system, so we have listed about the disadvantages of the existing system here. And proposed system, as mentioned, we are going to employ the two different models and two different modes, that is using image based and webcam based. All these details have been elaborated in the proposed system part. And coming to the advantages of proposed system, you can see the list of advantages of the proposed system. And coming to the system architecture, the input that we are going to use contain the yoga pose images and pre-processing selection made, and we have trained with VG16 model and the SVC model. And here the VG16 is being trained up for the image based yoga pose detection, and the SVC with Mediapipe is being trained up for the video based yoga pose detection. The prediction result will be one of the class, that is down dog or goddess or plank or tree or warrior 2. And finally we'll be showing the performance analysis and the graph part. So these are the system requirements, hardware requirements, and the software requirements. So this project can be executed in Windows 10 or 11. The coding language uses Python 3.10.9, web framework Flask, and the front end part contain HTML, CSS and JavaScript. And this is the reference, that is the IEEE base paper reference that we have used. So now let us see the execution of the project. Before execution, make sure that you have fulfilled the requirement that is mentioned in the requirements file with the exact version of the Python or the libraries installed in the system. So now let us into the source code folder. Inside that we have the yoga pose. Inside that we have the app.py file. So here in the address bar, I'll just type cmd and click enter. So the command prompt window opened with the exact location of it. Now type Python app.py and click enter, and kindly wait for a few minutes. So now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome, paste it and click enter. Now after a few seconds you can see the home screen or welcome screen of the project with the project title Yoga Pose Detection using Deep Learning. So now here you can just click this login menu. So now it will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and click this login button. So now you can see the login is success and click OK. So now it will be navigated to the image based yoga pose detection where you can upload the image and check it. So here kindly note that you need to give only the yoga poses images only. In case if you are giving some other images that is not relevant, it gives a random result of the classes that we have trained only. So here we have trained up only with these classes, so the system, the model will be recognizing only these one. So in case if you are giving some other images, it gives some random result only. So give only the images that is trained up accordingly. So now let us give an input for it and check it out how it works. So now in the test folder we are going to give from the test data set. So now let me start with the down dog folder. I'll just select an image. So this is the image I have selected. You can preview here in the index page and then click the submit button. So after submit button, you will be navigated to the prediction part where you can preview the image that we have selected, and you can see the prediction result. The prediction result is down dog. It is printed exactly. So now if you wanted to check again with some other image, again you can click this menu and go to the preview part. So just click this preview menu. It will be navigated to the preview part where I'll just go with the other image of the other class. This is the image I selected and click submit. So now you can see the pictured result is goddess. So now let me go to the preview part again, and let me select an image from this any of the image and click submit. So now you can see the pictured result is blank. Now let me go to the preview part again. I'll just upload an image from this class and then click submit. Now you can see the pictured result is tree. Now let me go to the preview part again. I'll go to this class and just select an image and then click submit. Now you can see the pictured result is warrior 2. So now let me go to the preview part again. So this time I'll just select an image, not from the test case. I'll just select from the image that has been available in the train part randomly. So these are all the images that is available here. So randomly I'll select an image here and then click submit. So now you can see it has been printed correctly as the down dog. So in this way you can just check with the other images that is available in the test or train or other images that is having the same pose. So now let me move to the next part, that is the webcam based prediction. So before clicking this webcam based prediction, make sure that it is connected to you're connected with your webcam in your system or laptop. After connecting the webcam, you can just click this webcam menu so that your webcam will work perfectly. So now let me select my webcam. Now I have connected and then click the webcam menu. So here once the webcam is turned on, it will not be available in this browser part. Here you can see there will be another window open. So once if you are checking if you are opening the webcam part, you may think that it is loading more continuously, but here another window opens in it, so it will not see. Here you can see, so it is loading. You may think that it is not shown here, but here you can see the other window opens here, the video part. You can just click this and you can check it out. So let me click this. So now you can see the video part is open. So now what I'm going to do, I'll keep this in the right hand side. I'll just open the images. So in the dataset part, the test and train, we have the images. So let me open some of the images and let us check it out. Right side part, I'll just keep the camera. I'll just show the camera to that images. So now you can see the left side part contains the image, and the right side part, video part, is the detection part of the video. It is being detected as the down dog. I'll just change the images now. You can see. See, some of the images it may also show plank or down dog, so there are some variations also will be available. We cannot expect 100% accuracy in it, so maximum it is showing down dog only now. So now let us check about the other images that is available in this case. now you can see it is printed as goddess. So some of the images it is classifying as warrior to goddess like this. Maximum it is showing the goddess images. Next contain the blank. So it is detecting the blank image now. So now we have checked about the blank. Now let me go to the tree part. So this is classifying as the tree perfectly. So you can see it is classified as tree perfectly. Now let me check out with the warrior 2. Now you can see it is classified as warrior 2 correctly. So maximum it is showing the warrior 2 perfectly. So now let us see about some other images from the Google. So now let us check about warrior 2 pose images. So I'll just keep the left side the input and the right side the video part. So now let me open this in a new tab. So click open image in new tab. So now let us check. So now you can see it is selected correctly as warrior 2. So now randomly I have selected a image from Google. Maximum it is showing the correct result. Let me check with this. So you can see it is corrected as warrior 2. So some of the result may also show wrong result, but maximum it will show the correct poses only. Next let us check with the warrior 2 we have checked. Now let us check with the down dog in Google Images. This is about the down dog images. So now let me open this image in a new tab. Open image in new tab. Now let us check the result. So now you can see sometimes it shows blank and sometimes it shows down dog. Now let us check with some other bigger image. So it is showing blank and down dog. Maybe because of image size it may show. Let me check with some bigger size. Down dog. Check with this image now. sometimes it is classifying as blank and down dog mismatched. Let us check in the video part. Let us check with this video part. So because of the image size, it was not detected in the Google images, so it was small images and not clarity, so it was not detected. But in the video part you can see it is detecting correctly. So let us check with the other video also. Let us check with the warrior 2 yoga pose also, the image in the video part. So now you can see the result. It is detecting as warrior 2. So now you can see it is rated as warrior 2 perfectly. So I have shown you with the sample of both in the image and video. So now let us move to the next part of the performance analysis. Just click this performance analysis menu, so it will be navigated to the performance analysis part. So you can check with the other cases of both image and video based with other cases also, that is available in the test train, or also from the Google images or from the videos also from the webcam part. So here in the performance analysis part, we'll be having performance analysis for VGG16 model. So this is the performance analysis for VGG16 model. Here it contains performance analysis parameter of accuracy, precision, recall and F measure value. So accuracy value 0.947, precision value 0.963, recall with 0.947, F measure with 0.947. So this is about the performance analysis, and we have the confusion matrix which contains the true and predicted label of the classes of down dog, goddess, plant tree and warrior part. So those all be depicted here. And finally let me move to the chart part. So just click this chart menu, so it will be navigated to the chart part. So kindly note that this is a static chart only. So this is a static data visualization chart. This is been representing the data set percentages. So here you can see which contains about down dog of 20%, warrior 2 of 25%, tree with 15%, plant with 25%, and goddess with 15% images that has been trained up with. So that is being presented in pictorial form. So here you can see the window is running continuously, the video window. If you wanted to close that, you just need to go to the command prompt window and type Control C, then only it will be stopped. The complete process will be stopped. So now you can see the complete process is now stopped. Once after clicking Control C, the whole process stops. So if you wanted to run again, you need to give python.app.py file. So now after clicking Control C, the whole project also will not execute after this. So if you wanted to run from the beginning, you need to do the python app.py file, which we had done earlier, and after that we can run it. And this is all about the project Yoga Post Detection using deep learning using Python. And thank you for watching.